Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be continuing with discrete random variable distribution, and today's distribution would be hypergeometric distribution. Now, what is hypergeometric distribution? We'll be seeing this today. There are many distributions, but we are taking only those distributions that has been asked recently in your examination and is important according to your examination point of view. First of all, we'll be discussing what is hypergeometric distribution, the concept from where it arises. So let us take an urn. This is an urn, and suppose this contains some white balls. This contains some white balls, suppose we don't know that, and some black balls. Okay, so this one contains some white balls and some black balls. Suppose there are n number of white balls, and the total balls that we have is n. So the black balls will be n minus m. These are our black balls, and this is our white balls, and the total number would be, total we have n balls. Okay, we take a sample. So let us take a sample here only. We take a sample, total sample of size small n, out of which n minus x is of black balls. The sample has n minus x black ball, and from here we can say that we have x white balls. So this is, we are talking about the sample, and this is, we are talking about the population or the total ones. Okay, so this is the concept where the hypergeometric distribution arises. From the urn, if we have to take out n number of white balls, and there are total n balls in the urn, and the rest ones are n minus m are black balls, and we have to take the sample of small n, where x is the white balls and n minus x is the black balls. Now here, when we have this kind of distribution, then we have to, suppose we have this kind of distribution, then we have to take the PMF of x. We have to find the x only, the value of x. So the PMF of x means the white ball is given as n c m, m as the white ball, n m c x. The above one will be of population and the below one will be of sample, and the remaining ones are n minus m into n minus c n minus x, which is the population and the sample number of black balls, and the total will be n c n. This is the total number. So this figure of ours, or this PMF, is known as the hypergeometric PMF, where x goes between 0, 1, 2 and so on up till infinity. So does m, so does n, and rest are the variables. And if we suppose that we are taking this hypergeometric distribution, x follows hypergeometric distribution, then its parameters will be m n x n, m n n. These three will be the parameters. This has been rarely asked in the examination but very important from exam point of view. Now let us discuss some of its properties. So the first properties of hypergeometric distribution. The first property as always will be mean of hypergeometric distribution. Mean of hypergeometric distribution is m upon capital N. If we talk about, here we are talking about the number of balls we are calculating for white balls. That's why the numerator is of white balls. If you have to calculate for black ball, then the numerator will be capital N minus m. If we are talking about variance of hypergeometric distribution, it will be m upon n 1 minus m upon n minus n upon n minus 1. You have to learn by heart all the things that I am telling you. The third property will be the mod. Mod of hypergeometric distribution will be n plus 1, m plus 1, m plus 2 upon n plus n with the integer bracket. Here it is also some correction, m plus 1 and n plus 2. This is our 1. And if we are talking about integer bracket, if this is the integer bracket, that means is the greatest integer which is less than or equal to x. If I take it as 2.5, so the greatest integer near 2.5 is, if I take it as 2.8, so the greatest integer near 2.8 is 3. But if it is less than or equal to x, then it will be 2. So the greatest integer near it would be 2 if it is less than or equal to x, and if nothing is given, then it will be 3. So that's what is meant by the greatest integer bracket. Now moving forward to the fourth property, which is our coefficient of variation. We know the formula for coefficient of variation, standard deviation upon mean. Now standard deviation is nothing but under root of variance. Variance have been given us as m upon n into 1 minus m upon n into n minus n upon n minus 1 upon mean. Mean is m upon n. If we divide them both, then this whole is cancelled with this, and this also comes in under root. So our formula will become as under root of 1 minus m upon n, or we can take it as n minus m upon n into n minus n upon n minus 1 upon n m upon n. This will get cancelled with this, and we get the value as n minus m n minus n upon n minus 1 into nm whole raised to the power half, or you can also write it under root. This is the coefficient of variation for our hypergeometric distribution. There is one more relation of hypergeometric distribution with binomial distribution. Let us discuss that as well. Suppose there are two variables, x1 follows binomial with n1 and p, and x2 follows binomial with n2 and p. Okay, these are the two things that it is following. Then the probability, the conditional probability of x1 is equals to r given x1 plus x2 is equals to k is given to us by n1r into n k minus r n2 k minus r upon n1 plus n2 Okay, and if we have to calculate the similar property but for x2 is equals to suppose it is s, given x1 plus x2 is equals to k, then it will be n2s n1 k minus s upon n1 plus n2 n1 plus n2 k. These are the properties when we have to find the conditional distribution of binomial. It follows hypergeometric distribution. Now let us move to some of the questions of hypergeometric distribution. The first question is on the board, which states that hypergeometric distribution tends to binomial distribution. Now this is one of the properties. I didn't discuss it because it was in your question. So the property says that whenever a variable, suppose a variable is x and it is following hypergeometric distribution with parameters n, m and small n. If it follows hypergeometric distribution with these parameters, then if this small n tends to infinity and this m upon n, which is the probability, tends to some probability p, then this x follows, solving these two conditions, this x will follow binomial distribution with parameters n and p. So these two properties are satisfied by the option number B, which is n follows infinity and m upon n follows p. Here this should be small n, not capital N. They have given us capital N. That depends on the question, but the property that is followed is here only, because here they are reversed, n upon n. That should remain the case because the total is above and the condition that we have to find is below. So that cannot be the probability. Here the probability is half, which is also not the case, and here probability reaches to 0, which is also not the case. So our option B is correct, and it should be small n. Moving forward to another hypergeometric distribution question, where they have given us the mean of hypergeometric distribution and they have given us the parameters. Now, in here, we know that the mean of any hypergeometric distribution will be n into m upon n. It is as simple as this, nothing more complicated. So none of them satisfies the answer, and hence our answer will be option number D, which is none of these. Okay. Now moving forward to another question, which is a, uh, a typical problem on firecrackers or this hypergeometric distribution. Let us see. A packet contains 10 distinguishable firecrackers. So our capital N, yes, capital N has been given to us as 10, out of which 4 are defectives. Since 4 are defectives and they have found the probability that all 3 are defective. So they are only x only. So x is 4 are defective. But here we have they have given the population. For population, m is equals to 4 are defective. So n minus m will be equal to 6, which are not defective. The probability that are not defective. This is total. This is defective, and this is non-defective. And here we are talking about the population. If we talk about the sample, so small n will be, yeah, we have to, if 3 firecrackers are drawn, they have given it in they have given it in alphabets, so you have to read the question carefully. So 3 firecrackers are drawn, means the total sample drawn is 3 at random without replacement. Without replacement is the case which is very important in our hypergeometric distribution. So without replacement word is very important for hypergeometric distribution. From the packet, then the probability that all 3 are defectives. means small x, all threes are defective, should be 3, and small n minus x should be non-defective, should come out to be 0. They have mentioned that. So if we have to solve the, if we have to state the PMF of a hypergeometric distribution, it will be MCX into n minus m c n minus x upon n c n. This is the case. So solving it here, px is equals to mcx, which is 4c x is 3, into n minus m, c 6, n minus x is 0, upon nc3, which is 10c3. If we solve this, cc0 is 1, into 4c3 is 4 into 3 into 2, upon 10c3 is 10 into 9 into 8. If we solve this, this 8 gets cancelled with 4 and 2, and this 3 cancels this, and we are only left with 1 upon 30. So this is the probability that when we take out a sample from this packet of 10 distinguishable firecrackers, and the number of defectives comes out, total of 3 defectives come out, if we take a sample of 3, is 1 upon 30, which matches our option number C. This is how we solve an hypergeometric question. It is easier because this kind of questions we have done in probability as well, but we didn't know which distribution we were following. Now you know that you are following hypergeometric distribution. Now this is the last question, and it has been given in your book, Gupta and Kapoor. I am just showing this, and this is your homework that you will be doing it in your homework. Just telling you that it is a variation of one of the mathematical famous mathematical problem, which is Banach matchbox problem. This is Banach matchbox problem. I am explaining you what the problem is. There are two matchboxes. Suppose there are two boxes of same length and breadth. This is box A, this is box B, and this has certain numbers of matchsticks, and this also has certain number of matchsticks. Okay, so one person have these two boxes, and a certain mathematician who is a mathematician, he always carries two matchboxes initially containing n sticks each. So this also contains n sticks, and this also. When he bought them, each time he wants a matchstick, he selects a box at random. Inevitably, a moment comes when he finds the box empty. Suppose I am the mathematician and I have two boxes. So I will, if I want a match, then I will randomly take one of the two boxes, take out the matchsticks, and then keep it again. Initially, it had n matchsticks, but one day what I found out was that if I keep on repeating such a process, then one day I will find out that one of the matchbox is empty before the other one. And when the suppose the B is empty, when I found out, then B doesn't have any matches left, and A has some R matches left. R matches left. When he found the probability that there are exactly R matchsticks in one box when the other box is empty. When this is empty, this has exactly R matchsticks. That probability we need to find out, and it is a question of hypergeometric distribution only. So you have to find out first the situations, and then you just have to take the PMF of hypergeometric distribution. It is an easier one. If you have any doubt, then you can ask in the comment section. We'll solve it in class only in the next time. And this is your homework. I hope that you'll be able to solve this question. These kind of questions have been asked in the examinations, so you will be able to do it. I have told you the background of this question, and your answer will be option number B. So I have told you the answer as well. In the comment section, you can even then you can tell which answer are your what answer are you getting in your solution, and we can discuss it if you want to. You can tell us that in comment section. And even if you're able to solve it, you should tell us in the comment section. We'll be more than happy. So this was all for today's hypergeometric distribution class. I hope that you got whatever we have done today in the class. And if not, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best and thank you.